In this video, I want to talk a little bit about circles, and it is first important to understand the technical definition of a circle, right? So a circle is a two-dimensional shape, right? And that two-dimensional just means that it's flat, and every single point that you put on its outside or circumference is going to have an equal distance, or it's going to be equidistant from the center. So let's take a look at the word equidistant. Equidistant. And this word looks kind of complicated, right? But it's important to just break apart the word. So right here, equa, you can just think of this as meaning same. So equa equals same. And then distant here, so it's same distance. And that's referring to if we were to draw a center and then draw a line to any point on the circle's circumference or perimeter, the distance of each of these lines is going to be equivalent. Now I'm going to talk a little bit about important vocabulary when it comes to circles. So imagine we were to draw a point perfectly in the middle of this circle. We are going to refer to this point as, the center. The center. And if you were to draw a perfect line from the center to any point on the circle's circumference or outside perimeter, this is going to be what is referred to as the radius. And now if you were to extend this radius to the opposite side, and I'll do this in a different color, this is going to be what is referred to as the diameter. And the diameter goes from one side to the other and always goes through the center of the circle, right? So this is the diameter. And then if you were to have a line that did not go through the center but still goes from one side of the circle to the other, and now we'll draw this in green. So if we have this point here on the outside of the circle that goes to this point here on the outside of the circle, this is going to be called a chord. And a chord is any line that goes from one side or goes from one point on the circumference of a circle to the other, but it does not go through the center. So from this point to this point could be a chord, right? Because, well, let me draw it a straight line like this. Notice how it goes from one side to the other, but it does not intersect this this center right here. And now I want to talk a little bit about the circumference of a circle. And to find the circumference of a circle, we have to define a certain ratio that helps us do this. So for any circle, if you take its circumference or perimeter, right, that's all circumference means. If you take the perimeter, and I'll draw this in green, the circumference, sorry, and then divide that by the diameter, which is, of course, this line here that goes from one point to the other on the circumference and goes through the center, you are going to get a specific ratio that we call pi. And pi is an irrational number, meaning it goes on forever past its decimal point, but it doesn't have a pattern, right? So pi is equal to 3.14159, and then so on and so forth, right? But it doesn't have a pattern. It just goes on forever. So what we can do is kind of rearrange this formula and give us something unique, right? So we can take diameter, and if we multiply it by both sides, we get diameter times pi is equal to the circumference, And notice here that the diameter is just double the length of the radius. So if we write 2 times the radius, times pi, we are going to get the circumference. And this is the equation that you'll see in your math class where you can get the circumference of a circle. And it can be written in multiple ways. For example, you'll often see it written as 2 pi r. 2 pi r is equal to circumference. But either way, this is going to give you the circumference of the circle. And now I'm going to talk about a little bit more advanced terminology of circles, but it's always just something good to know. So here we have 2 points on the outside of this circle, right? 2 points on the outside of this circle. And what we call the distance, or the distance traveled between these points, is the arc length. Arc length. Sorry. And you can think of arc length as just the distance from a curved part of a circle, but not the entire circle circumference. So there are two types of arc length. We have the minor arc length, and then the major major arc. And the difference between these is that the minor arc is the shortest path and the major arc is the longest path. So here, if we were to draw a line from this point to this point on the shorter path, along this line here, this is going to be the minor arc. And if we were to draw it on the other side along this is going to be the major arc length. And lastly, I want to discuss the difference between a tangent and a secant of a circle. So I'll write this here. Tangent and then secant. And these look like pretty complicated and weird words, but they're really not. So a tangent, or let me just start by saying both of these are terms that describe how many times a line intersects a circle. So if we have just one point where it intersects, or it's just going to intersect the outside of the circle at a single point, and I'll draw this here. And again, this is not the perfect circle, but you get the idea. And if we were to draw a line that just intersected that point, this is what's called a tangent. So this here is a tangent. And if we had a line that intersected a circle at 2 points, right? So we're going to have it intersect here and here. And I'll draw this. So another way you could think about this is just kind of an extended chord, which technically it could be an extended diameter too, but in this case the center would be somewhere around here. And a secant, like I said, a secant just intersects a circle at 2 points, and the tangent intersects the circle at 1 point. And we are done.